In previous lecture, we explained the mean and standard deviation, and also that they are parameters for description of normal distribution. For better understanding of a normal distribution, we need to learn more about the probability. Normally, we use probability to make a decision. For example, if you want to go out and uh, take your umbrella, you think about the raining probability. Is it probable to rain or not? To take the umbrella with you or not? Probability is always a value between 0 and 1, which 0 is impossible and 1 is 100% certain that it will happen. Well, in a statistic, probability is based on previous observations, which give us a proportions. For example, if we measure the proportion of the uh, blood types in a population, we can use it as a probability distribution. And uh, if we know these proportions in the population and we have a person that we don't know the blood type of this person, we can also, based on our observation, say that the probability of the blood type of this person is what. For example, the probability of the B blood type will be 0.08 or 8% of having this type of the blood. And if we want to see the probability of his blood type being B or A, then we can add the probabilities together, and in this case 0.43 plus 0.08 will be 0.51. So we can say the probability of his blood type being either A or B is 0.51 or 51%. And also, if we have two persons that their blood types are not dependent to each other, by independent we mean the outcome are not affecting each other. For example, in these two persons, in this case, if they are father and son, we cannot say that they are independent, so they should not be close relatives. Now we like to estimate the probability of both of them being B type. Then we should multiply the probabilities. In this case, 0.08 multiplied by 0.08 makes the probability as small as 0.0064. This is how we calculate different relation between the probabilities. The relation between the sample and the population is also a subject of uncertainty and probability. And the parameters that explain the distribution of this probability are the mean and the standard deviation. So any analytical statistic which relies on a connection between such parameters and the probability of the event which occurring, we can call them, or we know them as the parametric statistic. And for various reasons, parametric statistical analysis is only appropriate when we have quite large sample and a very large population. In this case, we can assume that the probability distribution of the observed data from the sample is reasonably same as the distribution in the population, but even then we cannot always use parametric approaches. Remember this part. So we can call data analysis with no assumption about distribution as non-parametric if we call the other one parametric. For particular continuous data, the distribution is normal. We also can call it the Gaussian distribution. This is normal distribution, the way it is. And since the sum of all probability values become 1, the surface area under the curve is also equal to 1, or we can say it covers 100% of the probabilities.